So guys, listen up. Yes.
Can you explain how you got?
Guys, quiet, please.
How you got F2 equals M2A?
So, what are the forces acting on block 2? Tension up and M2G and weight down, right? And so the so that I've said that this direction is positive. So I said M2G minus T, right? Okay. So we've done this problem a bunch of times already. So, but I want to just remind us. I've got an inclined plane. I have a block on it. And then the question becomes, and there's no friction. And the question becomes, what is the acceleration? Or first, what does a free body diagram look like? So the forces acting on this block are weight, or mg, down, and then a normal force perpendicular to the surface. And then, so the first step is free body diagram. Second step to solving the problem is to guess a direction for the acceleration, so we know what's positive, what's negative. I'm going to suggest that it's going to slide down the incline, accelerate down the incline, and therefore I'm going to break up my forces to be parallel to the incline and perpendicular to the incline. So with a dotted line, I'm going to draw in those two forces. I use a dotted line to make sure that I'm distinguishing it from the actual forces. The dotted line just means components. And we've done this enough that we know that forces parallel are mg sine theta, forces perpendicular Fn up, and mg cosine theta opposing. So that side there is mg cosine theta. That side there is mg sine theta. This is equal to MA parallel to the incline, MA perpendicular to the incline, and so that MA parallel is mg sine theta. The m's cancel out. Acceleration down the incline looks like g sine theta. So, yeah.
If theta is on a different triangle, how are you using it on that?
That's a great question. So this angle, we'll call this angle here theta. We'll call this angle here phi. And so we know that theta plus phi plus 90 degrees is 180. The three sides of a triangle, right? I've drawn that angle there is a right angle, correct?
How do you know that theta plus phi is 90?
That too.
How do you know that?
Oh, well, I don't know that, but I know that. I mean, I do know that, but what I know is that let's draw.
But how?
I'm gonna let's just work with me on this.
Oh. Is it like the line, the mg?
So straight down,
Yeah,
right?
Okay.
Right?
Yeah.
Okay. So having said that, we know that theta plus phi is equal to 90 degrees. And we know that this angle and that angle make 90 degrees, right? Call this like theta prime or something like that, right? So theta prime must equal theta. Okay?
Yeah.
You sure?
Yes.
Okay. That's when we thought it made sense. Let's make it complicated. Put an angle theta there. Let's put a mass there. Let's put a pulley there. And then let's have another mass hanging over the end. And we're going to call this guy mass 2. We'll call that mass 1. So what's the logical first step to doing any one of these problems? Free body diagram. And so we know at this point that we can draw a force down the incline, mg sine theta, a force up the incline of tension. We can draw a tension up here, make that M1G, sorry, and then down here, M2G. What's the next thing we need to do? There's one piece, if you've done the free body diagram, there's one piece that we need to make sure happens. We have to determine what direction the acceleration is going to be in. What direction shall we make the acceleration in? Anybody have a preference? Down. Down the incline or down the straight? Down the incline. Okay. So dotted line, acceleration is in that direction. I now write sum of the forces on mass 1 are, MA is equal to M1G sine theta minus T. Sum of the forces on 2, M2A is equal to tension is up minus M2G down. We will add these and we will come up with M1 plus M2A is equal to M1G sine theta minus M2G. Acceleration is equal to M1G sine theta minus M2G divided by M1, M2. So it's worth spending a few seconds. What are the limiting cases here? Give me the 3 limiting cases. Yep, hold on just a second. Limiting cases, yes.
Where did you get M1G sine theta?
From the previous page. We just got through showing the forces on an inclined plane. Right, we just,
Oh, yeah.
right, okay. So what are the, Gabe, limiting cases are? Okay, you have to answer my question first. I'm just joking. Ask your question.
The forces on the perpendicular planes, they're all equal to 0.
Yes. Okay. So what are the limiting cases I can talk about here? Yes. Yeah, I want big picture numbers. So the limiting cases are M2 equals 0. M2 equals 0 gives us acceleration is g sine theta. Limiting cases, we said M2 equals 0. What happens if theta is equal to 0? theta is equal to 0, what happens then? We get acceleration is equal to, acceleration of number 2 is just, excuse me, is just equal to m2 over m1 m2g, which is exactly the result we got last time, correct? And then clearly we could also do m1 is 0, in which case a2 is equal to g. So let's look at what happens. Suppose I tell you that, yep,
Quick question.
sure.
For when theta equals 0, why isn't it negative m2 over m1 plus m2 g?
It would be negative, thank you.
Should it also be negative for when m1 is 0?
Yeah. It's negative.
Perfect.
So you're sitting with M1, M2 over M1 plus M2?
M1 plus M2, yep. So just to repeat, when theta is equal to 0, A2 is minus M2G over M1 plus M2. And when M1 is equal to 0, A2 is equal to minus G. And we're actually going to see something a little similar to that. Let's suppose that M1 is 5 kilograms. The angle is 37 degrees, and M2 is 5 kilograms. So M2 is greater than M1. So when we plug this into our equation, we're going to get the following. A is equal to 50 newtons times 0.6, that's the sine of 37 degrees, minus 50 over 10. So A is going to equal minus 20 over 10 is minus 2 meters per second squared. So don't let the fact that we guessed the direction wrong scare you. You just come up with a minus acceleration, negative acceleration. Yep.
Really super quick question. So when we say negative g, would that be positive 10? Or
Where do you see negative G?
Well, for when we had like mass 1 equals 0 and acceleration 2 is going to equal
That just says it's going to accelerate at 10 meters per second squared, and the direction is opposite to that we expected. Any other questions on that? So flip the, yes. So let's look at that last problem. See if you can do that on your own.